the question. Now it says, now the statement says the graphs of g of x equals to 2x plus 1. This is a positive gradient. Both of them are. And now they say the inverse of g are shown in the diagram below. D and B are the x and y intercept respectively of g. C is the x-intercept of the inverse of g. The graphs, plural, of g and its inverse intersect at A. All right. This is good news. So now, what we know, you and I. At D, I know that the x value is 0. I'll find out the y now. At D, we know the y value is 0. We can find the x. And then at C, we know that the y is 0. And then again here, down there, we know x is 0. We're good, ne? Then we have a yellow point. That's where I believe both the graph, the x and the y, are gonna be exactly the same. I'm predicting that one. All right, fine. Before we go any further, let us do the following. Let's answer what needs to be answered. Here's the graph of g. If I want the y-intercept, I put 0 by the x, and then y is 6, correct? Then we have 6 there. I think we're happy. All right. If I take the same equation, 2x plus 6, make it equals to 0. 2x is minus 6. X equals to minus 3. That will be the x-intercept here, minus 3. We good, ne? All right, so now this is called the y-intercept. The inverse will be the x-intercept. The y becomes the x. If y is 6 here, x is 6 over there. Happy? So it's 6 there. This one is the x-intercept. The x-intercept becomes the y. If x is minus 3, y will be minus 3 here. So this is minus 3. That is the inverse. All right. So we're going to find this one. Yeah, I know the values must be the same. It's actually using y equals to x. We'll find that because I think I said it last time, when you're dealing with the inverse, you always draw a dotted line that passes through the origin. And that line is given by y equals to x. Together? All right. Okay, let me check if there's some people there. Yeah, someone is waiting there. All right, so let's keep it here. There we go. Okay. All right, so I'm gonna remove this line for now. You'll see the x and y will be exactly the same. All right, so now let's go back here. Number 1, write down the coordinates. Can you see? They want the coordinates. We are ahead of them. The coordinates of B, 0 and 6. So we got 0, semicolon, and 6. The next one, determine the equation of the inverse. All right. Original graph is 2x plus y. So we're having y equals to 2x plus 6. The inverse, I swap x and y, so it's x equals to 2y plus 6. So the blue turquoise, it's already inverse. But we must solve for x here. So I'm gonna bring the 6 over, so it's gonna be x minus 6 equals to 2y. Divide by 2, then you're going to have half of x minus 3 equals to y. So I can write that as g to the negative 1 of x equals to a half x minus 3. Can you see? So I'm gonna copy it and put it just under there, right here, so that you can see that the m is a half, the n it's negative 3. All right, we're done with that one. Determine the coordinates of A. Let's find A here. That's where the two graphs intersect. Fine, it's a point of simultaneous. That means I need to take this graph, and I also need to take, you can write it here, it doesn't matter here, equate them, correct? Alright, so this part here is going to get here. Let me tell you what the answer you're going to get at the end. You are going to get y equals to x every time. Every time when you do the graph and its inverse simultaneously, you're going to get y equals to x. X equals to y. You got it? Yeah, but now I'm proving, because I showed you there I was going to do that. So now I'm going to write the bluish one. It's going to be half x minus 3 equals to the yellow, which is 2x plus 6. So what I'm going to do, I'm going to take this one over there and take the number over there. So meaning I'm going to have minus 3 minus 6 equals to 2x minus a half x. Now watch now. Minus 3 minus 3 minus 6. What do you have? Minus 9. Yeah, minus 9 equals to, I should have said if you substitute in place of x. I didn't say it right last time. And then here 2 minus half, you're left with 1.5, which is 3 over the 2x, okay, or 1.5 or 1,5. You understand that, ne? Divide both sides by 1,5. Divide the 9 by 1.5. You get a 6. So I'm get x equals to negative 6. That's the first one. So that means when you're dealing with the coordinates of A, the x is negative 6. Now we need to get the y. Let's put it here. Put negative 6 there. You are going to have negative 12, correct? Plus 6, which is also negative what? 6. Can you see? They're the same. Y equals to the x value. So far, so good. Alright, it was simultaneous. Now let's finish it up here. Now they say determine the length of AB. What is the A? A is there. B is there. Alright, we are going to do the distance formula. The one you did when you were doing analytical geometry. So I'm going to write it here. I'm going to write AB. It's going to be the square root of, it's theorem of Pythagoras. I'm gonna say x 0 minus minus 6, so it's 0 plus 6 all squared plus 6 minus minus 6, it's 6 plus 6 all squared. You do the square root. Let's do it chop chop as it is, because we are smart people. Square root of 36 plus 144, I get 6 root of 5. Just put it, you'll see. Yeah, it's because 6 squared is 36, 12 squared is 144. They didn't tell me to round off to how many decimal places, so I'm leaving it as it is. If I'm rounding off, if I round off, I would say it's 13,42 units. We good, ne? Okay. Alright, so now they say calculate the area of triangle ABC. Triangle ABC. I'm gonna put this here so that it's beautiful. Triangle ABC. Alright, so let's make this triangle big enough. ABC. Alright, so triangle A, B, and then C. So which means it's gonna be that. So you are going to use what we call the area rule. Area rule. You know the distance of this one here. It's actually 6 square root of 5. You need to know one of the angle, either that one or this one or that one or that one, whichever you want. Alright? Yeah, which angle do you wanna take, do you wanna go after? You want this one? Let's find, yeah, maybe we can try to figure out what is this angle. Yeah. It looks like almost 90 to me, but I'm not happy. Or else we're gonna have to use something. I think it kinda look like 90. Anyway, fine. Let's find AC and BC and see which angle is best. Let's find this distance. This one. Yes, this distance will be the same as that one. So that means we have an isosceles triangle. This is 6 square root of 5. So which means that angle there, let's call it theta, it will be the same as that one as theta. Am I right? So they can be both 90 degrees. Then we can try to figure out this distance here, because I want to figure out this angle. Actually, we can find this angle. We can use angle of inclination if we want to. But for now, for you, it's gonna be a little bit tricky. So let's leave angle of inclination. Let's use sine rule. So I'm gonna call this angle here, let me call it alpha, like that. Alright, so let's work out this one here, this one, this distance here. Yeah, so where is it here? Yeah, it will be 6 squared 36 plus, yeah, so that distance, it's actually the square root of 36 plus 36. Trust me, it is, ne? Square root of 2 times 36. You're having 6 square root of 2. So it's gonna be 6 square root of 2. So this one is 6 square root of 2. Now we can find alpha, because what we want to do, we want to say we want to go area of triangle ABC. It must be equals to half. I want to use these two sides. Half of 6 root 5 times by 6 root of 5, and then multiply by sine of the alpha. That's what I need to figure out, the alpha. Alright, so we can use the cosine rule to get this alpha, because sine rule says you must have a side and an angle opposite to it. I don't have a side and an angle opposite to it, so it must be cosine rule. So that means I'm going to start with that one. I'm just going to write it direct here. Let me write it here. I'm going to start with this squared. Yeah, so it's going to be open bracket 6 square root of 2 all squared equals to, the other one it was 6 root of 5, and then all squared plus the same thing, 6 root of 5 all squared minus 2 times 6 root of 5 times 6 root of 5. We could have done that angle using the thing and then sine of alpha. Alright, so this is how it looks like. It's because I kept the square roots, that's all. So I can transpose everything to one side. So in other words, we can move this one to one side and then we divide by what's in the circle. That's all. So let me do that. Let me write it in blue. So which means we are going to have open bracket 6 square root of 2 all squared minus open bracket 6 square root of 5 all squared minus into 6 square root of 5 all squared. So I have moved this. Now I must use here divide by that to give me equals to sine. It's gonna be equals to sine that part. So divided by negative 2 open bracket 6 root of 5 into 6 root of 5, like that. So all of that equals to sine of alpha. Actually, if you're looking for the alpha one time, you can actually say this is shift sine of everything on the left. I just putting it one time. It's shift sine of that. So it's that. I know you guys, you love to press numbers step by step. Me, I'm doing it one time. Do your own thing. Sorry first. Sorry. Let's fix this. It can't be sine. It must be cos here. I put a wrong thing. It's cos of alpha. Yeah, because we're doing cosine rule, remember? Not sine. Yeah, it's cos of alpha. Let's just fix that one. Yeah, it will be cos to the negative 1 of that. Good. Personally, I'm getting 36,87 degrees. Are you getting the same thing? Yeah. Maybe it's because you rounded off. So now we can give them the answer for that one. We can now answer this one here. We can now say here you're gonna put that angle. Let's just do it. So it's gonna be in bracket 36,87. I said there is a way we could have found that angle. We could have used inclination. So let's do this black one here. Get the area. Alright, my one is giving me somewhere about 54, because it's 54,000,12862. If we say round off to 2 decimal place will be this. So really your answer is just 54 units square, or square units. Alright, yes.